Good evening. So today we are going to discuss the equations of motion and proof of equation of motion by calculus method. So let's see to it. First equation of motion, which is v is equal to u plus at. We started with acceleration formula, which is a is dv upon dt. And then we do cross multiplication. So by cross multiplication, we get it becomes dv is equal to a into dt. Now we integrate it. So integrating within the limits. So dv, a is constant, so we integrate only dt. Now dv velocity, what you want to prove is v and u. So it becomes lower limit is u, upper limit is v, time 0 and t. And so dv becomes v. And then we put square bracket u and v. A is constant, dt becomes t. Then we put square bracket and limit is 0 and t. So we have now upper limit minus lower limit is equal to a t minus 0, and therefore we get v is equal to u plus at. Thus we have proved this by calculus method. We can discuss by graphical and direct method, but in 11th standard we must know by calculus method. Similarly, we have second equation of motion, which is s is equal to ut plus half at square, right? So proof can be because in this we have distance and initial speed. So we start with formula of speed, which is v is equal to ds upon dt, and then we do cross multiplication. So by cross multiplication we get, so it becomes ds is equal to v into dt. But what we see, what we have to prove in that, v is missing. So v is replaced from first equation of motion, which is u plus at, and then multiplied by dt. And now we'll integrate. So integrating within the limits, we get. So what we get? Fine. So it becomes ds integration, then u into dt multiplying. So dt is variable plus a into t dt. Now, if you look at it, ds having s only, so 0 to s. Time having 1, so 0 to t, 0 to t. So ds integrate becomes s, then we put square bracket 0 and s. U dt becomes t, limit is 0 to t, plus a. Over here, power over t is 1. So x and dx, nx and minus 1. So it becomes 1 into t, 1 minus 1, limit 0 to t. Because this will be s minus naught is u t minus 0 plus a sorry, some correction. It is integration, no? So it will be added 1 plus 1 divided by 1 plus 1, and which means it becomes a, and then t square by 2, 0 to t, which means s is equal to u t plus this half will come first, half a, and then within the bracket t square minus 0 square, and therefore it becomes s is equal to ut plus half at square. Hope you are getting it. I am doing it with most simplest way, most simplest manner I am trying to do, right? Now third one. Third one is v square minus u square is 2as. This we start with the first. First we start with acceleration formula dv by dt. And then we rationalize. We multiply and divide by ds. So when we multiply and divide it by ds, so this ds upon dt can be velocity. So it becomes a is equal to v dv divided by ds. Now we do cross multiplication. So what we get? It becomes v dv is equal to a into ds. And then let's integrate. Integrating within the limits. So it will be v dv, limit is what we have to prove, v square minus u square. So u lower limit, v upper limit, a ds integration 0 and s. Thus it has power 1. So we add 1 in the power and then we divide. And then we do this square bracket u and v is a, ds is s, 0 and s. So we get it v square by 2 and limit remains u and v. A, this is s minus naught. So upper limit minus lower limit divided by 2 is equal to as, and then again we do cross multiplication. So by cross multiplication we get v square minus c square is 2as, right? Proved. So these are the three equations of motion and calculus proof. Although you have one more equation of motion that we write in terms of S and F. That proof we'll do in the next video, and then we'll take some numericals also. So thank you so much. Do like, share and hit like button, share it with your friends and write your comments. Thank you.